bit the problem that I think comes up for some people. You know, we've all experienced situations where you get some kind of question, and if you don't see kind of right off the bat a pathway to an answer, it's easy to get kind of feeling that you're stuck. And in particular, I think that is sometimes an issue for this class because we're trying to ask questions in a somewhat different way. That is to say that we're not just kind of defining, here are a few categories of standard problems and, just like repeat these over and over again until you're ready for the midterm and you'll get, 5 of those on the midterm. Instead, to a certain extent, the questions should be sort of, conditionally independent of the training given the underlying concepts. There is new things to think about rather than just remember. So I guess one way of saying this kind of problem that I'm kind of warning you against here is, people who are used to kind of training on categories of questions through repetition to kind of saturation, they look at a question and they want to sort of remember how to solve it. It's like, I've trained on this, so, I recognize this question, I know how to solve it. That can get you into trouble because if you look at a question and you don't immediately remember, okay, I know the solution strategy for this problem, there's a feeling like, oh my God, I don't know what to do. And people can get stuck in that situation. So what I really want to counsel you to do and try to practice a little bit today is don't try to remember the answer. Instead, just think about what you're being asked. And I would submit to you that in many or most of the situations where someone feels stuck, unsure of where to start, it's not the case that they actually don't know anything relevant to the question. Actually, they do. And simply getting your sort of salivary juices flowing on a particular question by just starting to pull out relevant knowledge that you have either in the form of relevant words, relevant pictures, relevant equations, will do good things for you, both in the sense that, from a totally practical point of view, mercenary practical point of view, they'll get you partial credit. You just put down relevant things. We will be looking for anything that we can give you partial credit for. And second, they may very well just lead you gradually to the zone where you start to go, oh, I sort of see how this connects to figuring out the solution, and you start doing down that path to get you towards the solution. So I'd like to go through this a little bit. I'll start with a simple example question. Let's say we had multiple hidden variables, which I'll just call theta 1, theta 2, theta 3, and let's say they're associated with each one observation. Let's call them x1, x2, x3. A simple example of this might be where the observations are like each one roll of a dice, and the hidden variables might be, whether the dice is a fair dice or a loaded dice if somebody's cheating, for example. And you might be asked some kind of question about, okay, well, how might we compute a probability like this, a conditional probability of one of our hidden variables, let's say theta 2, to be in a particular state, say the loaded dice, given some sequence of observations. And here I'm just using the shorthand notation x with a vector over it to indicate that it's multiple x values, in this case x1, x2, x3. And the question is, how would we go about formulating such a probability? And this could be in a completely general case, given some information graph. So, you know, what kinds of words, pictures, or equations could we bring to a question like this?
You could draw a graph from thetas to their respective observations.
Mm-hmm. Right. So in a question like this, you might be given some explicit information graph, and then you could use that to think about the process that would get you to this probability. What about words? Are there words that come to mind in this?
Posterior probability.
Absolutely, absolutely. So even just being able to put up a name for what you're being asked, turn it into words, can really help you down the path towards figuring out how to get the answer, right? So, you know, when you hear the word posterior probability associated with this, what does that make you think about how you could get it? Bayes' law, absolutely. So, you know, there's a very simple situation where, you know, either just coming up with the equation, oh, we'll use Bayes' law, or coming up with the word posterior probability, which kind of leads you towards using Bayes' law. Either of those would really, really help get you to where you need to go. I'm also going to kind of go to talking a little bit about a picture here. So here's an example of a problem that I've seen in people trying to answer a question like this. So, for example, somebody might correctly come up with the idea that, well, you know, this question focused on just one of our hidden variables. So there's other hidden variables that are in play here, and what are we going to do about them? Well, one way we could deal with them would be to use summation to, you know, basically eliminate them from the total joint probability of all of our variables. And that's a really good idea, and definitely a path towards getting the right answer. But I've seen the situation where people will actually, you know, stop short right there and say, okay, you know, there's my answer. Again, this is a situation where I would argue that, you know, just in basic terms, thinking about what words apply to each of these things would really help you out. What is this? Well, basically, it's going to give us this, right? When we do that summation over theta 1 and theta 3, it's going to give us something like this, right? Where basically we've squeezed out the theta 1 and theta 3 from the combination of all three thetas, and then we're just left with just theta 2, okay? So, in words, what is that? Yeah, it's a joint probability. So, you know, even just at the level of words, I would argue that someone who stops basically there, it seems to me like they're not even consulting the vocabulary that they themselves know. You know, I mean, if they look at that and say it's a joint probability, and if they look at what the question was asking, and they call it a posterior probability, you know, they know joint probability, posterior probability, not the same thing. So why did they stop there? To my mind, if someone stops there, it looks like they're not really going back to their words that they know to make sure that, you know, their answer checks against what they're actually being asked. Okay. So let's say someone got through that and they said, okay, well, I've figured out how to get this, and I want to get that. You know, how could I go about this? And you know, you've already supplied one great path for doing that, Bayes' law. Another thing that I find really useful that I would just suggest as a picture for you to go to, again, if you're feeling stuck on some kind of conditional probability question, what's the picture that comes to mind when we talk about, conditional probabilities and joint probabilities? An information graph is one way of formulating this. Another way is like a Venn diagram. I find that this can really help whenever there's confusion about kind of direction and the relationship between joint probabilities and conditional probabilities and so on. So how might we apply that to a question like this? Well, let's say, this is the target now that we're trying to get. We could draw a picture of this in Venn diagram terms, right? So just for the sake of convenience, let's say that our x variables are being colored as a red. So in other words, we said the event was our x observations were a 2, a 6, and a 6. In other words, x1 equals 2, x2 equals 6, x3 equals 6. And let's say that event we're just going to mark as this red subset of our probability space. And then we could say that the event that theta 2 is loaded dice would be represented by the blue subset in the joint probability space. So then the question is, let's say, we've got this and we want to get that. Well, the Venn diagram picture. I mean, even if you didn't remember Bayes' law or didn't turn to the page in the equation sheet that shows Bayes' law, as people who have fun with a question like this, sometimes don't do. You could work this out for yourself straight from the picture. I mean, it's sort of like, well, this is a joint probability. What is that joint probability? Well, it's basically that little zone where I've got both of those, the red and the blue, that's the purple here, and then joint probability, well, that's just divided by the entire joint probability space, this whole big square. Whereas, this conditional probability, we're basically saying, well, what's the probability of this blue, given that we're inside the red zone? Well, that's just going to be this purple overlap zone divided by the red zone, purple over red, and we can rewrite this in the usual ways, multiply denominator and numerator by white, or I guess you could say divide both numerator and denominator by white, and we'd end up with basically the joint probability divided by the unconditional probability for x. And that's the classic relationship, right, that is basically Bayes' law. But the point being that there are many paths to get to this answer. Coming up with the word posterior probability and then thinking, oh, Bayes' law. Or for that matter, looking at some kind of conditional probability question that you're being asked and going, oh, well, usually I get the answer to conditional probability questions using Bayes' law. Again, that would work for you. Or going to the picture and thinking about it in terms of kind of the first principles would also basically get you to the answer. Any questions?
So the answer to this would be the thing we figured out to be the joint probability over the probability of x.
Yeah. So we're getting this posterior. We can get it more or less straight from joint probability over unconditional probability. And if you were given a particular information graph structure, you'd probably be able to simplify this potentially. But I just wanted to focus on kind of the core idea of using all three approaches to think about a problem if you're feeling like you don't know where to start. Okay. Are there other problems that you have run into where you felt like you were getting stuck and you'd like to see how we might go through this exercise of trying the three different ways of thinking to get started on that problem? Anything?
actually have a little bit more general question.
Okay.
On Monday, how much of Monday's material is going to be on the midterm?
So I think what I would say is what I said before, that has been kind of formulated in terms of covering up through homework 4. So there was a bunch of material kind of in lecture mode on Monday, basically warning you about dangers of hypothesis testing interpretation. There aren't going to be questions about asking you, what are all the things you have to worry about, and this was, sort of for your future life. It's not something on the midterm. I don't know if that helps. I mean, I think the basic, the midterm, it doesn't need to cover all the material because we're going to have a final later, right? So I'm trying to keep more recent stuff kind of out of the picture.
Okay. This is just a comment also. I think I speak for most of the classmates. They were pretty confused on Monday about what was happening.
About which part?
The lecture part. So just we couldn't really ask questions, so that made it a little bit more difficult. So I think.
Let me see if I can zero in here. So the concept tests or the lecture part?
I think they were both pretty difficult. But,
well, we're going to go through some more concept tests today. Hopefully that will clarify. Yeah, I think that's probably the best way to go into it, is look at specifics and
it's just a more
talk about
warning
specifics.
that there's going to be a lot of questions.
Will extreme value testing be on the midterm? Is that something that can be tested?
I think it's in homework 4, isn't it? Where we have questions about formulating a p-value. No?
Okay, so my thing is that a lot of times I don't know what a solution is going to look like. Like, I'll read the question and I don't even know what the answer will look like. So that makes it hard to start. So I don't really know how, help clarify that. But I just wanted to voice that.
Well,
It's been an issue for me.
I'm trying to think about
It's like when I
if we had a concrete example. I think that sometimes makes it easier to talk about
Yeah.
useful details.
I think maybe I have an idea. Maybe, are you talking about, like, if the question is asking, like, give a likelihood model or something,
Yeah.
and
like
then you're
really
not sure,
vague
like,
terms.
what it's gonna look like? Does that make sense?
Like the
Like
form of
what
a
it means to
solution.
Yeah.
give a likelihood model.
Well, so let me try to zero in a little bit. So taking an example like that, where you're presented with some kind of example problem, and now we're talking about, well, what kind of likelihood model might we apply to this problem, something like that.
Yeah.
So the specific term likelihood model, would it be the situation that the term itself is not making sense, or is it that it's unclear about how what choices to make, what assumptions to make?
Yeah, I guess it's also about the assumptions. Or sometimes, like, you'll look at the answer, and the answer will make sense, but it'll include, like, hidden variables, I guess, that are hard to think of from the beginning. Like,
Okay, so
like for the homework, for example, there was lambda in there, which was the copy, or not the size of the genome or whatever, and that. And, like, in the reading, that kind of helped you understand what the homework was about. Like, lambda's not defined anywhere, and it's that kind of thing where it's like, I don't really know what this is.
okay, so here's a good point. So one way of thinking about this is that each model likelihood model intrinsically brings along with it hidden variable or hidden variables, right? So if we talk about like a binomial likelihood model, then there's a hidden probability theta, for an event to occur versus not occur, right? We talk about like a Poisson model of an event occurring over time. There's a intrinsic hidden variable associated with the kind of like what's the overall density of that event per unit time. So one way of saying that would be that if a question told you, the hidden variable is the density parameter lambda, then that's basically telling you that the likelihood model has to be, say, Poisson, right? There's kind of a one-to-one association between where we're assuming a particular hidden variable choice and kind of the likelihood model that goes along with that assumption about this is all that matters, right, for the problem. This kind of is a classic problem for science classes in the sense that, strictly speaking, if you wanted a test question to be fully predefined in the sense that there's no choices left except how to do the algebra, basically all the science is gone. All the scientific decisions about what assumptions shall we propose for, what model shall we propose for a problem have to be given as in the language of the question, and there's nothing left basically but algebra. So I think that the challenge that you're pointing out is here you are being explicitly asked to think about, well, what choice of model might we apply to this specific problem, okay? I would emphasize that in this class, we really are disciplined about sticking to a very small set of possible models. I mean, the only models that we have talked about in this class and are going to talk about, basically, is we're talking about the binomial, the Poisson. I guess we've talked a little bit, we've used a little bit normal distribution, and I think that's it. So we're not trying to stress test your knowledge of probability distributions. And so, it's pretty high reliability that, if you're trying to choose among likelihood models, it's like not very many to choose from here. And the logic that you have to apply is each model comes basically with an independence assumption. Right? If we talk about the binomial, we're saying that we're assuming that all of the observations are independent of each other and occur with exact same probability, which is just given by this value theta, right? If that's a reasonable assumption for a particular problem, then that's a very simple place to start, right? In this particular case of choosing a likelihood model, you're basically asking yourself, I have very few choices, and among those choices, each one of them has an independence assumption. Which one seems to fit this problem? And then, you could just propose a likelihood model and say why you think its independence assumption is appropriate for your problem. As long as you say something that's coherent, we're going to at an absolute minimum give partial credit for your proposing something explicit and justifying it. Does that help? Does that start to address what you're asking about? I mean, the other side of the coin would be basically what I've just been saying. That is to say, don't expect to just look at the question and go, oh, I remember this, you know, I know how to start writing down my answer, I know exactly where I'm going, I follow the following algorithm. Instead, think about what you're being asked, what's relevant, what concepts are relevant to it, and then it's like a iterative approximation algorithm, right, where you get closer and closer and closer to the answer as you apply relevant things and kind of see what's relevant. Is that helping?
Yeah.
Are there other aspects of that that you'd like me to talk about?
No, not that I can think of.
Okay. Other things that people want to ask about right now? Okay. Well, then, what I think we can do is go right ahead with some of the further review exercises that hopefully will address the things that you were just wondering about, Arthur. So,